So what we are doing here is that, dear students, just keep a just watch, just remember these points so that we have discussed in the previous class the reaction between compound and mixtures. Okay, and we will simply say that compounds are those substances that are in which the elements are chemically combined together. In which the elements are chemically combined together. Okay, so we have done this one, compound and mixture. Just keep an eye on it. I'm just going to ask you. Just let me update the topic. Okay, then do this one, please. Keep an eye over it. Note it down. Means just revise it fast.
So we have to write this down.
No, we have discussed this one in the previous class. And if you have not written this one, then you have to note it down. And I'm going to explain you.
Sir,
Yeah. So what is the difference
what's
between,
sir,
yeah. What are you saying?
what's the second word in the second point of compound?
What is second? The constituents of compounds show their properties. So let me explain you. We have not done this one. So let me explain you each and everything. What is the difference between a compound and a mixture? Okay. So whenever a compound is going to form, there is always we will simply say that if we have H2O, okay, like we are having H2O, hydrochloric water, okay. Water is in two hydrogen atoms combined together. Now you have another one is sugar solution. You have water molecules, like these are the water molecules, okay, and you have sugar solution in between. You have sugar particles. Okay, these are the sugar particles, square shaped sugar particles. So this is a mixture. This is a mixture. In H2O, the two hydrogen atom chemically combine together with oxygen atom. So, okay. So we'll simply say that here, the water, the two hydrogen atoms are chemically combining together with the oxygen atom. So we'll say that it is a compound. It is a compound. And it is a mixture. So what is the difference between mixtures and a compound? In a compound, elements are chemically combined together. Means like one hydrogen atoms will chemically combine with another hydrogen atoms with the oxygen atoms. The two hydrogen atoms are combining together with one oxygen atoms. Okay, in water, every water molecule, irrespective of their production, whether you are getting water from any reaction, if it is water, then it must have two hydrogen atoms and one oxygen atoms. Okay, got it? Got it? And if I'm talking about the mixtures, in mixtures, the elements or the substance are not chemically combined. They are physically bounded. They are going into the intermolecular space in between them. They are going into the intermolecular space between them. So we'll call them mixtures. We call them mixtures. So in compound, the elements are combined together in a fixed ratio by mass. Like for example, in every water molecule, there will be two hydrogen and one oxygen atoms. So ratio of the hydrogen to oxygen atom is 1:8. 1:8 is the mass ratio. Is the mass ratio of hydrogen. Means like for example, in water, one water molecule, we have two hydrogen atom and one oxygen atom. So one hydrogen atom has one mass, so two hydrogen atom will have two mass. One oxygen atom has 16 mass. This you will next chapter. So don't it be if it is, it's okay. So 1:8, or and they have fixed ratio. Like for example, ammonia, in ammonia there will be one nitrogen atom and three hydrogen atom. Irrespective of the, you can't say that whether the US water is going to have two hydrogens H2O2, they are producing special water H2O2. which is having more oxygen, which will benefit your health. No. If it is water, it must be H2O, irrespective whether the water is formed anywhere in the world, not in the world, outside the universe, like on the moon, Mars, anywhere. If it is water, then it must have 2 hydrogen and 1 oxygen atoms. Okay. So, but you can see that the mixtures can have different variety. Like for example, if you have a tea is a mixture. Okay. It don't have any particular formula. You can visit to different shop. You will find the different taste of tea. Okay. And so this will say that that the same product, same ingredients are used, but the taste may be different because of the compositions are different. So we'll simply say that in mixtures the compositions are not same. Okay, they may change, but in compound the composition is same. Elements are combined together in a fixed ratio binding. And moreover, in the compounds, the chemical properties are not shown. Like in a compound, like it is made up of 2 hydrogen and 1 oxygen. When 2 hydrogen atom combined with 1 oxygen atom, they will form water molecule. They will form water. Now you know that water, hydrogen is a fuel. This help in combustion, help in burning, And this water extinguish fire. Extinguish. So if water is extinguishing fire, okay, it is not showing any properties of hydrogen and oxygen. You know, hydrogen. Sarah, are you doing something else? So what I'm saying here is that Rafe, please make your camera so that your face is clearly visible to me. Rafe, your camera, your camera is just like over your head. Your face is not visible to me. So what I'm saying here is that in a compound, the constituent from which the compound is made up of, they are not showing their property. Like the hydrogen in the compound, does the hydrogen in water show its property? No. Hydrogen as a fuel, does water burns? No. Oxygen help in combustion. So we can say that water is a mixture of hydrogen gas and oxygen gas, which should be extremely flammable because it is having its own oxygen which help in combustion. It is having hydrogen. So even just a spark of in water can let it continuously burning, keep on burning, but it is not so. Water do not burn because in water the hydrogen and oxygen are not showing their property. They are not showing because it is a compound. In compounds, the constituent do not show their property. However, if you take a mixture, like you take the mixture, like you make a cup of coffee and it is not sweet, you forgot to add. So what you forgot to add? Tell me. If you are just making a coffee and it is not sweet, okay, so which substance you have forgotten to add?
Sugar.
Sugar. So you know that before adding sugar has a property of sweetening, and after adding into the coffee, it is also adding sugar sweetness to the coffee. So before and after the change, they are showing the same chemical properties, same properties. So we'll say that in a chemical chain, the constituent show their property after the change also. Means in a mixture, the constituent from which it is made. For example, if you take the mixture of iron and sand. So iron has a property of sticking with magnet. But do you think that it will get stick? Okay, it will not. It will get stick easily when it is mixed with sand. So iron when mixed with sand, it is showing its property. So it is a mixture. So in mixtures, the composition is not fixed. The constant after the change, they show their property. Okay, and they don't have any mixture, don't have any formula, uh, while the compounds have molecular formula or chemical formula. Okay, compounds are formed by chemically combine. When the elements are chemically combined together, the compounds are formed. But when the mixtures, if I'm talking them in mixtures are formed when the two or more substances are physically bonded together. Got it? Understood? Yes or no? Yes.
Yes.
Yes, sir.
Yes, sir.
So please note it down. Note it. You done?
Yes, sir.
Yes.
So elements chemically combined together, elements are physically combined together in non-proportionate manner when there is no fixed ratio. The constituents of the compound don't show their property. The constant of mixture show their property. The constituent can't be separated by simple physical method. Like, this is very important. A constituent we can't separate them by simple physical method. Okay, we can't separate them by simple physical method. But like for example, you are having hydrogen. So if you just evaporate the water, like you start heating this water. Okay, if you start, so it will if it is solid, it will get converted into liquid, H2O liquid. If you keep on heating, it will get converted into H2O gas. So it will simply say that if you are heating, if you are vaporizing it, it will remain water. It will not disintegrate. It will not give you hydrogen and oxygen gas. So by simple physical method like heating, boiling, evaporation, okay, the constant can't be separated. Means you can't separate hydrogen and oxygen from water. Okay, it will remain. Its state will change, but it will remain. So its constant can't be separated. But however, if you take a sugar solution or a salt solution, okay, and you heat it, so you will find that all the water will get converted into gas, and you will get salt in the solid in the form of beaker in beaker. So you will find that you will find beaker. The salt solution will be there. Got it? Are you getting my point? So when you heat salt solution, you will find that salt is there, and but the hydrogen gas gets evaporated. Sorry, water get evaporated. So you will find that we can easily separate the water and salt on heating from salt solution. So, but you can't separate the compounds. You can't separate the constants of compound. Like you can't separate when you are evaporating the water. You can't separate the hydrogen gas and oxygen gas. So simple. The constant can't be separated by simple physical methods such as filtration, evaporation, boiling, and cooling. Here the constant can be separated by simple physical method like filtration, evaporation, cooling. Okay. Next is they can be separated by chemical methods. We can separate them by chemical methods. Yes, by passing electricity. Okay, we can separate the hydrogen gas and oxygen gas. Okay. Here they have fixed formula, fixed melting and boiling point. Like you see, water has fixed melting and boiling point. But here the compound do not have the mixture don't have the fixed melting and boiling. Are you getting my point? What I'm saying? Everyone?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So have you noted it up to here?
Yes, sir.
Yes, sir.
Next. Now if I'm talking about this sodium, like salt, moving towards the solution, because we have discussed the elements, we have discussed the compounds, we have discussed the mixtures, we have discussed the difference between compound and mixtures. We have discussed what are atoms, what are elements. Okay, let's move towards the solute and solvent. Okay, what is solute? You know that when a solution is going to form, like for example, Sana, are you doing something else? Show me a copy. You are doing something. Okay. So what I'm saying here is that when I'm just teaching you, everybody is requested to not to write. When I'm speaking, you are not allowed to write. You have to listen. When I said note it down, then you have to note it down. You start writing. Okay. In between, when I'm speaking something and you are writing something, it means that you are not listening my voice. You are not getting what I'm saying. Okay. So let me explain you that what is a solution. A solution is always formed when there is a solute and a solvent is going to form. Solute and a solvent. Let me explain you this one. Like for example, you are making a sugar solution. You have sugar and you have water. You make it as sugar solution. Sugar solution. Can you tell me that what is the state of sugar solution? Solid, liquid, or gas?
Liquid. Sir,
So
Liquid. It would be liquid. And what is the state of water? Solid, liquid, or
liquid.
gas? Liquid. What is the state of sugar?
solid.
Sugar.
Solid.
Solid. You check that here the water is in liquid state and the solution is also in liquid state. So the same. It will be solvent and it will be a solution and this will be a solute. Always keep in mind a solvent and a solution have same state. Got it? Like for example, you have mercury. Mercury is liquid at room temperature. Okay. You have sodium. You are making this mixture sodium. This is solid at room temperature. When you mix them together, you find sodium amalgam. Sodium amalgam. Okay. You need to note it down that sodium amalgam has a state solid. It has solid state, and here sodium has solid state. Can you tell me that which is solvent here? Mercury is liquid, sodium is solid, and sodium amalgam is solid. Can you tell me which is solvent?
Sodium.
Sodium is solvent. Yes, I was just thinking that you always assume that solvent is liquid. No. Here I'm saying that if the state here of the solution is solid, then in the mixture which is solid is considered to be a solvent. Here it is solvent. Sodium is solvent and mercury is solute. Are you getting my point? State will be same. State will be same. Like for example, you have water, minute water droplets in air will gives you a fog. Fog is gas. Air is gas and water is liquid. Can you tell me which is solvent here?
Air.
Air is solvent and water is solute. Got it? Got it? This one?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Similarly, if you have smoke particles are carbon particles, like smoke means carbon particles which are solid. Okay, not solid. We say carbon particles, particle or dust particle we are taking. You have solid. When you mix it with air, it will gives you, which is gas, it will gives you smoke. Smoke is also gas. Which is solvent here? Which is solvent here?
Air.
Air is solvent. Because same will be solvent. If it is gas, this is solvent. Other will be solute. Got it?
Yes.
Got it? Yes or no? Same
Yes,
if
sir.
I'm talking about here, is that noted down, note this down. Solute plus solvent will give you solution. I guess water. Make this one please. Note it down. एक minute. Note it. Done?
Yes, sir.
Yes. Hello. Hello. Hello.
Now, here we are having, so solute and plus solvent will gives you solutions. Okay, you are getting this one?
Sir,
Yes. Are you
am
getting
I
this one?
audible?
Yeah, you are audible. Is I'm audible to you?
Yeah, yes, sir.
Okay, so we have divided the mixtures into two parts. One is homogeneous mixtures. Second one is heterogeneous mixtures. Note it down. And further, we have divided the homogeneous mixtures into one part, that is true solution, which has uniform composition. And heterogeneous mixtures, we are of two types, suspension and colloids. Please note it down. Make this table. Noted? Okay.
Yes,
So
sir.
what do you mean by homo? Homo means, what do you mean by homo? The word homo means same. Word homo means same. And hetero means different. Hetero means different. Okay. Heterogeneous means different. So if I'm talking about this heterogeneous mixtures, what do you mean by hetero? Hetero means different and homo means same. Okay. So when there is a same composition, like for example, what do you mean by uniform composition? Like you take a glass of water, okay? You add some salt to it. Adding some salt to it, if you take a sip of that salty water, either from the top or either from the bottom, okay, you will feel the same taste. It means it has uniform composition. Means throughout the solution, if you take a sample of 1 ml from that solution, almost all of them are going to have same number of particles of the solute. Okay, like for example, you have some, means they are going to have uniform composition. Like for example, you have some salty water, salt solution. Okay, and in that salt solution, you take 1 ml solution with the help of some tube. You take one ml of solution from it. Okay, you take 1 ml of solution from it, and you take the sample test. So you will take in 1 ml. If suppose 50,000 particles are present of sugar. Okay, suppose, or salt. So if in the next 1 ml, it is approximately the same. We're not saying it can be 50,001, it can be 50,000, 400, 49,000 something. It can be, but there cannot be much difference. They have the uniform composition throughout the solution. Okay, but just imagine, have you seen you are just eating an halwa. Okay, halwa, you know everyone. We add kishmish, raisin to it, halwa. Okay, halwa, everyone. If you are Indian and you belong to the Indian, say your mother belongs to the Indian subcontinent, then you know halwa. Halwa, everyone knows. So if you take up means one tablespoon of halwa, okay. Sometime it can be a kaju in your mouth. Another time it can be kishmish. Another time it can be nariyal. So there can be different component there. Means you are not going to have the same taste, same composition. So we'll say that it is not homogeneous. It is heterogeneous. Heterogeneous means different composition. Means every time you are not going to get the same product in your mouth. Okay, that is called heterogeneous mixtures. Got it? If you take the like if you are having 100 means heterogeneous mixtures, like for example, you dissolve some mud in water. Okay, you find that if you take them after some time, you will say that mud will settle down, or the particles every time they will not going to have means as you go down and down, you will see that more mud particles are at the bottom, and at the top there are less number of mud particles. Okay, or the sand particles. Why? Because the sand gets settled down. So we'll say that it is not going to have uniform component. Got it? Sometimes you take some sand particles, sand, and you add some iron fillings in it. Sometimes somewhere you can get more iron filling, sometimes somewhere you can get less iron filling. So it is considered to be as non-uniform compositions. Okay. So what do you mean by the non-uniform composition? Non-uniform composition means that the substance or the solution is not going to have same composition. They can have different number of samples of particles if you take from different samples from the same solutions. Okay, got it? Like I have given you the examples of halwa. The same thing. True solution has uniform composition. Like you have ruhabza you made in your home. You even if you take the first sip or the last sip, it terms and condition is that you are not going to dissolve the sugar. Incomplete sugar you are not going to dissolve, because if you dissolve incomplete sugar, you will feel the taste more sweetness in the bottom last. But if you completely dissolve and you made ruhabza, you drink it, you will find that one. Okay, got it? So that is called uniform composition. So please make this one. Please note this one that I'm going to explain you. So homogeneous mixtures, okay, attraction force is there. Sometimes we make different particles. Like for examples, you see that iron. In the iron, you add some carbon particle to it. Like in 98% iron and 2% carbon. Carbon atoms have smaller size, and iron particles have a bigger size. So iron atoms when we are just making it like this way. Let me explain you that why we are just making this homogeneous mixtures. What is the benefits of making sometimes the mixtures or alloys? Like for example, these are the iron particles. Okay, they are attached like this composition. On using heavy loads, like for example train, if train is moving over it, they can shift their composition like this way. They can come like this way here. So from here there is a slide. Okay, there is a distortion. This is on the atomic level. So you can say that if we are just making a pure iron railway track, then it can distort. It can result in this bending. Okay, the strength will be decreased. What we do, we add iron. These are the iron atoms, and carbon atoms are smaller in size. So we add iron and we add carbon atom in the interstitial space. When we mix it, this carbon atom goes into the interstitial space. Now the first layer cannot slide over the another layer, and we called it steel. There are two kinds of steel. One is stainless steel. Second one is only steel. So iron railway tracks are made up of steel. Iron mixed with 2% carbon, 98% iron, 2% carbon. We called it steel. Okay, so these are the homogeneous mixture. So these are the homogeneous mixture because almost iron particles we are having carbon. We have the same composition. So this is the homogeneous mixtures. Okay. Now, what is the main difference between the homogeneous and the heterogeneous mixtures? When we are just talking about the homogeneous mixtures, you need to keep in mind that what is the main difference? That how can you define that these are the homogeneous mixtures and these are not the homogeneous mixtures? So in the homogeneous mixtures, if we pass the light, okay, the particle is so small that even though if the light is traveling, the light cannot strike on this one. You see that if this bottle is visible to me, so if this bottle is visible because the light is coming and it is being reflected and it is reaching to our eyes. Okay, so even though if a particle is visible to you or anything visible to you, the light should fall over it, and from that one it should refract back and it should go into our eyes. That is only possible when the particle is enough in size that light can strike over it, light can fall over it and get refracted, scattered in all direction, like this way. Like this is the light particles. Okay, here you can check, this is the light particles, this is the particle, and if the light is coming, so this particle, if it is bigger in size, enough bigger in size that light falls over it, then it will scattered everywhere. Okay, so if an eye is here, if a person is sitting here, his eye is here, so this particle will be visible to him. But what happens if this particle size is so small that even though the light cannot fall over it, light cannot fall over it, or means the particle is so small in size that it cannot scatter the beam of light. So you have this torch. These are here the outside the dust particle are big enough that they are scattering the light. But if you pass this torch with a uniform composition solution or a true solution, you will see that no path of light will be visible here. No path of light will be visible. Path of light will be visible because when the particles are strong enough, suppose the particles are bigger in size, then the path of light will be visible. But you see that if there is no scattering here, no path will be visible of light. Light path will not be visible. So the particle size is so small in true solution or in homogeneous solution that it do not scatter the beam of light. You have to keep in mind, Samia, let's look at this. What I'm saying here is that if the particle size is bigger enough that it can scatter the beam of light, and if the beam are scattered, if the light is then the path of the light will be visible to the solution. The path of the light will be visible. But if the path of light is not visible in this one, there is dark, no light is being scattered here. Okay, and here again it is scattering because here is air, and air have dust particle, and they are bigger enough in size that can scatter the beam of light. So here you see that you have seen the torch. You see when you lit up the torch, you find that this torch means the path of the light is visible because the dust particle is bigger enough that it can scatter the beam of light. You went to the theater, you find that in the movie theater, the projector's beams is scattering. Okay, and the beam is visible to you. The same thing here also, but here in the true solution, The particle is so small that it will not scatter the beam of. But in the heterogeneous mixtures, the particle is big enough that it can scatter the beam of light. Are you getting my point? What is the difference between homogeneous and heterogeneous mixture? The main difference, Saad, Hanan, and other student, please turn on your camera. Furkan, you are not turning on your camera. What is the main difference between the true solution or a homogeneous mixture and a heterogeneous mixture? In homogeneous mixtures, if we pass a light through it, there will be no path visible. No path will be visible. They will not scatter the beam of light. The particle size is so small that even though the light cannot strike over it. But in true solution, sorry, in heterogeneous mixtures, the particle is bigger enough that if we pass the light through it, it will scatter the beam of light. Understood? Understood? And this scattering of beam of light is called Tyndall effect. We call it Tyndall effect. So heterogeneous mixture shows Tyndall effect, while the homogeneous mixtures do not show Tyndall effect. So heterogeneous mixtures, here the path is visible. Path of light is visible. But in heterogeneous mixture, no path is visible. Okay, no, nothing, no visibility. Nothing is visible. Not visible anymore. So make this one, please. Make this one. Done?
Yes.
Okay.
Next. Now write down the difference between the colloidal, true solution, homogeneous mixtures, true solution. Homogeneous mixtures are also called true solution. Okay. So note it down. The difference between heterogeneous mixtures. Colloidal solution, the particle settle down here. The particle do not. I'm just removing this one. Note it first. Homogeneous mixture, particle do not settle down. While in colloids, particle do not settle down, but in suspension, particle settle down. Okay. Homogeneous mixture can't be separated by filtration. Colloids can't be separated by filtration, but suspension can be separated by filtration. They have uniform composition. They also have uniform composition. They don't have uniform composition. It do not scatter the beam of light. It scatter the beam of light. Scatter the beam of light. Furkan and Saad. just I'm asking you, you are enrolled with us, okay? How can I take your responsibility whether you are getting good marks or not if you are hiding yourself behind the camera and I'm not able to see whether you are writing something, you are noting something, are you getting your something? I'm not getting your face expression. I'm not saying whether you are listening to me, whether you are doing something else. Furkan, you also. Every time in the class,
Sir,
I'm
I
not
am
going to
connected to my
remind
computer.
you. What are you saying?
Sir, I am in my computer, so this computer is not having a camera.
You are not having camera. In the previous class, you were saying same thing. Then
Sir,
I
you can check, sir, the computer which I am now using for today. This is not having camera.
so you have to keep in mind that we have your responsibility. Okay, you are studying. First of all, you are studying online. Okay, online teaching is very good, but if it is done, why we are having a strength of only eight to nine students in a batch? Why there is a need? Because in when we are having 40 students, we cannot see whether which student is writing, which is not writing. Having eight student, nine student in a batch, we can recognize, we can check whether everyone is writing properly or not, whether you are maintaining your notes or not. We are having a short batches. Even though you are not turning on your camera, then we are just we are not getting what's the benefit of having short classes. We can have 40 students if in a batch if we if we need to teach them having camera there or your camera off. So just keep in mind this is your responsibility that you can't hide yourself because you study in the school. Here is also you should do like that. You noted, everyone?
Yes, sir.
Okay. So what is the main difference between a true solution and a heterogeneous mixture or a homogeneous mixture and a heterogeneous mixture? You can check here that colloids and true solution almost have the same property. Like you see, particle do not settle down, particle do not settle down, can't be separated by filtration, can't be separated by filtration. Have uniform composition, have uniform composition. They almost have same points. But what is the main difference between the true solution and the colloids? That colloids particles scatter the beam of light, while the true solution or the homogeneous mixtures do not settle the beam of light, do not scatter the beam. The path of the light will not be visible in true solution. However, in colloidal solution, the path will be visible. Okay? Understood? Yes or no?
Yes, sir. Yes,
Noted, everyone? Noted, everyone?
yes,
Yes,
sir.
sir.
Okay. Are you understood, everyone? Understood?
Yes, sir.
So you have to keep in mind this one. Okay. That they are going to have. This is the main difference. So we have studied the two solution colloids and suspensions. Let's have an important one here. Just a minute. What are the examples of colloidal solution? What are the examples of colloidal solution? Like for example, hydrogen gas, oxygen gas, N2, carbon dioxide. These are true solutions. Okay. But if we are having dust in between, like hydrogen gas, oxygen gas, carbon dioxide, there are different samples of gas are there. So pure air, fresh air, without the dust particle. If we have only gases, not smoke, pure hydrogen gas, oxygen gas, nitrogen gas, carbon dioxide, pure, then it is a true solution. But if we add dust, then you see that dust can scatter the beam of light, so it becomes heterogeneous, it becomes colloids. Okay, got it? Same here. Water and carbon dioxide when mixed together, they form true solution. Like in cold drinks, water and carbon dioxide mix. They like ethanol and water mix. Like solids and solid, like sugar and water mix. Okay, salt and water. So these are the examples of true solutions. Okay, got it? What are the examples of colloids? Milk is a colloid. Blood is a colloid. Okay, milk and blood. Example, milk and blood. Write down the examples of true solution. And here examples is blood, milk, fog, smoke. Here suspension, we have mud, muddy water, soap solution, muddy water, muddy water. Note it down, please. You done? Noted, everyone?
Yes, sir.
Okay. So what we are having here is now we have some common examples, like you have to note it down. There is a dispersal phase, like I've shown you that, for example, if I'm saying fog. So in fog, you see fog is gaseous. Fog, water droplet is mixed with air. So you know, if air is gaseous and fog is gaseous, so air will be the solvent, okay, and water will be the solute. So here we have dispersal phase means solute, dispersion medium is solvent, and type of colloidal solution is aerosol. An example is fog, clouds, smoke, etc. So when we have solute as liquid and solvent as gas, we call them aerosol. So please make this chart fast. We called it fog. This is the last table that we are going to make. After that, we're going to end the class. Done?
Yes, sir.
So
To 4, you have noted up to 4. Write 4 more. Like you see that gas and liquid. So liquid is solvent. So here the form is also liquid form.